Well, good evening, everyone.
So to share our current understanding of the science behind these trends, please join me in welcoming Dr. Steve Wright.
Is there a way I can get a little bit of light on the audience? Like just enough so I know you're still there and haven't all gone home? Yeah, about that is perfect, for me at least. And hopefully, yeah, this is a huge screen, so that ought to work. So, all right, yeah, I did speak down here back in 2017, a substantially smaller room. This is quite the theater. At U of M, I never got to talk in a place this good. So maybe I should move down here. Yeah, so what I want to do is first go briefly through, really briefly, the history of the climate change science. I don't think this audience needs an extended bit. Some look at the impacts that we need to be paying attention to, and then what I've found is most interesting of all, about the last third of my talk, are the different renewable energy and just solution sets for climate change that I'm finding. I'm actually more optimistic than I was 5 years ago because I'm really seeing some tangible progress that I want to share with you. So that's kind of what's up for the next hour. And, oh, perfect. Uh-oh. There we go. A couple of brief points that I've found are important to get everybody on the right wavelength. And the first one is that we don't want to confuse climate with weather. And when we talk about climate, and particularly global climate, we're talking about global trends over decades. Whereas when we're talking about weather, we're talking possibly locally, like, you know, the temperature here today was 88 degrees or whatever, or we're talking about short time periods, like just the last few weeks. Climate is the long-term view, and particularly the whole Earth. And so, like these statistics that it was the hottest day in the entire Earth, that's the sort of climate fact that we pay attention to. The second point is one that I think probably most people don't find intuitive until they think through it. And that is, when we think of the entire climate system, we look up at the sky. Well, it turns out the atmosphere is the smallest component of the global climate system. It's what delivers to us the day-to-day weather. But the real engine of the climate of the Earth is the oceans. And we're going to see a couple of stats on that to illustrate why. And so this is why you can't really just measure atmospheric conditions and be looking adequately at climate, because the big engine is the oceans. It isn't even the cryosphere. People might think, well, it's the Antarctic ice cap and Greenland, and it isn't even that. It's the ocean. Remember how deep the oceans are, all full of high heat capacity water. So all this started with a Bitterrooter. Did any of you know Charles David Keeling? Anybody? His family's had a ranch here, you know, a small ranch for 50 years. He's the most important earth scientist of the century. And it's kind of interesting. Of course, he worked out of Scripps in La Jolla, so he wasn't here year-round. But that's him riding up the Snowball chairlift with me a number of years ago. And what's he famous for? The Keeling curve. It's even named after him at this point. He started measuring atmospheric CO2 at Mauna Loa in 1957. And when I look backwards, I realize, and so I guess to see, so he started here, and he told me later that it was easily by 1970, he could see what was going on. Atmospheric CO2 is going up every single year. And of course, if you can think back to back then, nobody thought globally about anything back then. We didn't have any satellites, so we never had a global view of the world. And this was the first evidence that humanity was having a global impact on anything. And so this CO2 record has been called the most important geophysical data set of the century. And it's because it was our first early warning that global warming was on the way. Now, often I'm asked, well, how do we know this isn't just natural variability? Yeah, it's getting warmer, but couldn't it just be that the sun's getting brighter or something like that? And so this slide is meant to just give you an instant visual that here's the variance of solar irradiance, here's what volcanic eruptions do, and of course, here's what greenhouse gases are doing. So we've measured this exceedingly carefully, and we absolutely know that natural variability comes from the Milankovitch cycles, which are how the Earth wobbles in its orbit. Meteorite strikes, like what wiped out the dinosaurs, volcanoes, things like that. But over this last 60 to 80 years, it's unquestioned that this is human-driven greenhouse gases. And in fact, this is kind of a busy slide. I don't expect you to crawl through it. Kind of notice some things that are in here. Aerosols, a cloud. Blue means it cools off the atmosphere. Red means it warms it up. Scientists have measured every single one of these components to very high detail, and including the long-lived greenhouse gases. There's CO2, there's methane, some other ones. You add and subtract all of this, and you get a net warming of about 2 watts per meter squared. Now, I used to explain that to people by saying it's what a Christmas tree light is. But now with LED lights, that's wrecked that example. And so maybe we're old enough to remember the old time incandescent Christmas tree lights. But it's like a little nightlight worth, but that's on every square meter of the entire planet is being loaded with this 2 watts per square meter of additional energy. So that's just the greenhouse, the global warming physics in a nutshell. Uh-oh, boy, my thumb's got to get quicker. So here's just the NOAA tracking of global land and ocean measured temperatures. I'll try to be really explicit when I'm talking about computer model results or when I'm talking about actual measurements, because it matters. And so you can see since 1880, and particularly since 1980, this is when I arrived at U of M. So over the course of my entire career, we've never once had a below average year of global temperatures. It's just a continuous ramp upward, including these all-time records of this last summer. Now this is the one I was referring to about what we see with the oceans. So this is a paper that put all the components in a heat balance for the whole Earth. And if you can imagine doing that, what you see is that the land and atmosphere is just a tiny sliver down here, starting up since about 1980, and look at this. This is where all the energy is going. And I love this one. It's getting 228, all these zeros, sextillion joules per year of new energy. Now, can you relate to that? I can't either. I mean, it's so over the top. But I think it makes the point that we are loading to this just incredible amount of additional energy into the Earth system, and 90% of it's going into the ocean. And the hard part of that is we don't know when and where it's going to come out. And so that's part of what we're going to look at a bit in a few of the next slides. One of the things, the way it's coming out, is sea level rise. This isn't even a storm in Miami Beach. This is just a high tide that nowadays comes up through their storm drain system. We know that sea level is rising 2.3 millimeters a year. And so we actually know this quite accurately. Believe it or not, we measure it with satellite altimetry. And so this higher slide is the satellite record that started in 1995. And part of this is from thermal expansion. Water, as it gets warmer, expands. And the other part of it is simply melting of the ice caps and glaciers. Loading all that energy into the ocean, it probably doesn't take much imagination to say, I wonder if that's going to show up in tropical storms. And sure enough, what they see happening now is that this is an increase in frequency. The smaller storms, the category 2 and 3, have only changed a little bit. But the number of storms that get up to category 5 has gone up something like 300 to 400%. And again, this is over a multi-decade trend. This isn't just a single year. NOAA's actually defined a category 6 hurricane because they expect one to happen any year now. In fact, I think in the Pacific, they've already had a typhoon, they call them over there, that reached category 6 speed. So one of the impacts of all that heat content of the ocean is stronger storms, and it's clearly quantified and being measured to be the case. So not so much more hurricanes as when they get started, they get stronger. And in fact, the hurricane that was off of, Acapulco last year, went from a category 1 to a category 5 in 24 hours flat. And even the specialists couldn't figure out how that could possibly happen. In one day, it go from a 1 to a 5. So clearly the ocean has more energy than it used to. I don't need to explain this one to this crowd of how the glaciers in Glacier National Park are retreating. The park website has a very good set of these historical photo pairs if you're interested. And of course you see exactly what this example shows. And glacier, 95% of the glaciers on Earth are retreating. There's a couple here and there that aren't, but everywhere else you look, they are. The Antarctic ice cap is another big one that we monitor by satellite with very high accuracy. And of course, it melts out in the summer, the southern summer melts out, and then it increases in the winter. And the 2023 is the lowest midwinter maximum that they've ever seen. So we're clearly seeing that the Antarctic ice cap is slowly melting. Now it's miles thick, so it isn't going to be gone in a few decades. Every once in a while I read kind of hysterical climate misinformation like it'll be gone in a few decades. And things are tough enough already without exaggerating what's happening. That's all I'm going to do of the global trends. I could do a lot more, but I want to get on to other things. This is how Montana looks. And this is, you maybe have seen the Montana Climate Assessment. It came out in 2017. It's available online for anybody who wants it. And they looked at temperature records and temperature and precip records all across the state. So this is measured data. And what they saw, they cut the state into zones like this. And this is the degrees per decade of warming. So about 0.4 of a degree per decade it warms. So over 5 decades, that's about 2 degrees Fahrenheit. And this is what you see is very consistent all the way from the west side to the east side. It's curious that way, and it's very, very clear, and that we're getting warming all the way across the state. Now, precip is a different story. On the west side here, we're getting a little bit less annual precip. Again, this is looking at 50 years of record, and so a ½ inch is not a whole lot, but when you're only getting 14 inches, which is about what Hamilton and Missoula get per year, then that's a measurable decline. Note, though, that on the far east side of the state, their precip is actually going up a little bit. The overall summary, though, is that the precipitation for the state is not in any huge way changing, which we could say maybe is reasonably good news. Now let's look at the future and look at what the global climate models project. And I first want to explain how they look at a place like Montana. They start by running the model for the entire world. They typically, what they do is they start 100 years in the past, run through the present, and then 100 years into the future. And if they get to the present and they're way off, those models are just thrown out. They've shown that they can't even represent the past correctly. So the only models that are used are the ones that come from like 1900 to the present with solid accuracy. And those are the ones we use to look forward. They then do what they call downscaling. So you zoom in to the Pacific Northwest like this, and these are the cells of the model data set. And then we add things like the local topography particularly, and rain shadow effects and things to give it a little more local accuracy. And the wintertime precipitation, the models expect our wintertime precip is going to go up a little bit. So far it hasn't, but this is what the models expect. Now, of course, part of that is that some of it's going to start falling more as rain and less as snow. And we already have too many January snowstorms where it's just perfect that morning. And if you don't go out that day, by the next day it rains on it. And you go, oh, I missed it. What I worry about is the summertime. This is, again, model simulations for about 40, 50 years from now, approximately. And what they expect is temperatures to be a couple degrees even warmer, really continuing the trend we're already measuring, but less summer rainfall. And when you put together warmer temperatures and less rainfall, that's not a good combination. And so recognize these are the global climate model simulations for the Northwest. Now, one of the things those models do not do, they're not really designed to do, is forecast occasional extremes. And probably most of us were around here just a couple years ago when it hit 116 in Portland, 108 in Seattle. Are you kidding me? I grew up in Seattle, and it used to be front page news when it went above 80 degrees. We'd get all excited. And so these are temperatures in that heat wave of, what was it, 2001? No, I can't even remember the exact, or no, I mean 221. The climate models can't predict these sort of occasional extremes, and yet they're starting to happen. And our theory, they kind of break our theory in a worrying way. So my climate science friends that look at things like this, it makes them kind of extra nervous, because the GCMs are forecasting kind of the average trend, but they're not calculating the variance around that trend, and particularly these extreme events. And this is one that even the climate specialists don't know how it happened. And of course, NOAA keeps track of the billion-dollar weather-related disasters. They've been doing it for a number of years now. And so these are all different kinds of disasters, but all related to weather. And the main point you see is that as the years are ticking by, we're just getting more and more and more of these weather-related disasters. And of course, part of it is there are more people around. There's more houses and infrastructure around, but part of it also is the changing climate is just driving more and more of these extreme events. Now, one of the summaries that the climate scientists use that I found is useful to talk an audience through, because it sounds counterintuitive, is they say when we think of the future climate, they say, well, the wet regions are going to get wetter and the dry regions are going to get drier. And I've read this in newspaper summaries many, many times. And you kind of think, what? How can, is it getting drier or is it wetter? One or the other, what's the deal? And once you think it through, it makes sense. So we know the air temperature is getting warmer. That's clearly measured and forecast. So you have air temperature that's getting warmer, which evaporates more water. Now, if you're a wet landscape like the Amazon, it evaporates more water into that atmosphere, and so it then generates more rainfall and thunderstorms, so the wet region got wetter. But what if the air is over a dry landscape like a desert or like Montana? Well, it gets warmer, but there is no water to evaporate, so that air gets hotter, but it doesn't get wetter, it gets drier because there's just not that much water to evaporate into it. And so depending on whether you're looking at a wet or a dry landscape, both of these statements can be true. And that leads me to kind of a summary conclusion that I've had for Montana for a couple of decades now. For us, the issue really isn't going to be just raw increasing temperature. You know, this isn't Phoenix where we're going to be bumping 120 degrees pretty soon. Our issue is really going to be the aridification of our climate, our water balance as we think of it, of water in versus water evaporate, is going to get, already is getting more and more negative, or more and more drier and drier. And that generates disturbance dynamics like we're seeing right outside today that will be more important to us than just the temperature alone. So these are the things that I think we in Montana want to be paying particular attention to. Our water balance, as this crowd I'm sure knows, starts with the winter snowpack. And so I remember I was up, this is up Laird Creek, feet on a north-facing slope on March 4th. And you look at that snowpack and you think, uh-oh, this is going to be a tough summer. And so it isn't that every summer is going to be tough as much as when we start out a summer low on snowpack, and so our hydrology is already behind, that's the summers where we need to get ahead of the curve of how to manage for those. I think it was a great example last year that Flathead Lake they couldn't fill up. Well, this year starting way back in March, negotiated to not draw it down as low, draw it up earlier, and it's been full all summer, even though we didn't really have a very good snow year. And it was a good example of his anticipating a dry summer, and within the range of things that we have management options, we're able to help the system a lot. We did a study a number of years ago, all these different rivers in Montana, and we weren't looking at annual river flow or discharge. What I was interested in is what's the low flow in August, the kind of bottom level flow, because that's the crunch time, particularly for the aquatic ecosystem for our cold weather trout. Well, you see from 1950 to 2007 is every single one of these rivers, their August flow is lower on average, is a trend going lower than 50 years ago. And so this is where the fishing restrictions get started, and the hoot owl restrictions based on we're really losing that summertime river flow in a very measurable way. And of course, everybody wants the water. We want the water for recreation and aquatic habitat. The farmers want the water for irrigation. The thermal energy industry wants the water for cooling towers. So everybody wants this water, and yet I can clearly illustrate that our overall water balance is in a negative trajectory, and is going to basically stay that way for the foreseeable future. It's just going to get drier. And of course now this crowd doesn't need to hear the wildfire part of this, part of the story. This is what these fires look like from the space shuttle. I saw this picture years ago, and I've just kind of been a bit enthralled by it, because we never see them looking down. It actually looks way cooler than when you're in the middle of it, and it sucks. And so this is our fires from below. But I could give an entire hour seminar on what we've found about wildfire and climate change in the West. This is a sprinkle of papers. They just show that the humidity deficit is accelerating, which increases evaporation rate. That just lengthens the potential fire season. And kind of to make a summary of it, past the details, our fire season is starting earlier. It goes later into the fall before things cool down and get wetted down by fall rains. The other part of it is the mountains are getting dry to a higher elevation than they used to. And so we have high elevation spruce fir forests that the snow would barely get melted by July, and they'd never get dry enough to burn. Well, now they get dry enough on dry years. And so now we're getting burning all the way to higher elevations that we didn't used to get. And so you add all those factors together about the fire season and the climate, and then you get what we're seeing right outside the door. All right, this is a whole different topic. Let's now stand back and think through the global carbon cycle. And of course, this is what I worked on in my career. And so this is the best one-slide summary that I have. It's done by the Global Carbon Project. Every year it's updated. And it basically shows, kind of ledger style, the sources of anthropogenic CO2. And about 11% of the CO2 is from wildfires and agricultural burning. So that is not a minuscule fraction. But then by far the big enchilada is burning fossil fuels. There's no mystery there. So about 89% comes from fossil fuels and about 11% from a variety of land use emissions, let's call it. Where does it go? Well, we now understand that 26% of it dissolves into the ocean. It's just like like soda pop, carbonated water. The CO2, a fraction of it dissolves into the ocean. We know it's about 26%. About 29% is absorbed by the terrestrial biosphere. This is my box. This is what I worked in, was calculating global photosynthetic capacity of the biosphere. And then whatever's left over that the land and ocean didn't take up ends up in the atmosphere, 48%. And of course, that's the Keeling curve. That's what's left over that keeps increasing the concentration in the atmosphere. And so this is the three places that all this CO2 is going that we now understand pretty well. And this is updated every year, and these proportions stay really very, very much similar. Now, we can then start boring into the actual emission rates. And of course, we have this because oil, gas, and coal are commodities, and so their production and use is actually in the economic world quite well measured. So this really isn't scientific. Well, I guess economists are scientists. That was kind of a cheap one. I like to do that when I know there's economists in the... So this is simply economic data, not so much earth scientist data. And you see, since 1990, we've gone from about 22 gigatons to 37. And that's gigatons of CO2. We've had a couple of times, the 2008 economic crisis, where it dipped for a year. I was in Sweden, and we were so excited when we saw this dip. We were sure we'd reached peak emissions for the world. We've now turned the corner, and it didn't take very many years to show, no, we hadn't turned the corner. Of course, COVID was another dip. If anything, I'm surprised how small that dip was. When you think of how much of the global economy shut down, as we all remember, I would have thought it would have made a bigger difference than it did. And then, of course, we're back on track of increasing emissions. Now, what are the sources? Very clearly, coal is by far the biggest emission source. Oil next, and gas, and natural gas next. Producing cement isn't incidental, as you can see, so that's in there. But by far, coal and oil are and gas are what we got to work on. Pure and simple. What countries are doing it, and this is where you see, since the year 2000, the Chinese economy just take off. And so now China basically has higher emissions than most of the rest of the world, developed world, and we're still the top. Now, that's the bad news, is we're still the top. still about double what China is. But at least the nice part is for a good at least decade, we are lowering our emissions. People are surprised to hear that we're actually decreasing our emissions and have been for a decade. And so, and we're going to talk about that some more. So you see from those couple slides that by far the first thing that we got to quit doing is burning coal. And particularly burning coal for electric power, because we have 5 other ways to produce electricity. It's an easily substitutable power generator, and this isn't even talking about the public health effects. This is just talking the climate effects. So we, luckily in the U.S., we pretty well, the coal industry is on the way out and they know it. And the problem is, like the coal mines in Montana, their solution is, well, let's export more to China. And so that doesn't help. I like to tell people, the barge full of coal going over, they then burn the coal and the CO2 comes back faster than the empty barge gets here. The CO2 comes back over our head. And so when it's burned anywhere on Earth, it's all part of the problem. Then you start digging deeper into the whole fossil fuel industry. And one of the things that really is kind of shocking and demoralizing is how much subsidy the fossil fuel industry gets, that they've built on for decades. And in a way you can't blame them. They asked for various perks. You know, they decide they want to come in and start a new oil field, and they get the local county to give them land. This happens lots of times. They get their land for free. Then they get a promise they don't have to pay taxes for the first 5 years, and there's endless of these subsidies that you never hear about unless you really dig in. But every oil patch around this country, I'll bet I could show you a half a dozen layers of subsidies that they're living on. And these subsidies amount to more than what we pay the Pentagon. When the oil industry, brags about how cheap oil is, and boy, we got gas for $3 a gallon. The legitimate cost of a gallon of gas is probably something like $7 or $8. That's what Europe has been for decades. And so imagine how different our economy would be if we were paying $8 a gallon for gas. And that's really what we ought to be paying. And so, geez, I'm definitely, okay, maybe I'll try with this hand. So there's a lot in the financial world nowadays. About the only way to fight this is there's getting to be a lot of push for divestment of investment in fossil fuels, and basically starving the fossil fuel industry for capital. And a lot of the major universities have committed to divesting all of their investments from fossil fuels. And so this is one of the means of trying to, in effect, right the playing field. Geez. Okay. There. Now, then we start looking at how renewable energy, and particularly for electric power production, how things are going. And I think we all recognize that literally the cheapest new electric power, if you need to generate new electric power, the cheapest thing in the U.S. is either wind turbines or solar panels, depending on your local climate. They are now in absolute dollars cheaper than even running a natural gas turbine like Northwestern Energy does. Coal plants like Colstrip, the power companies are trying to shut down because they just cost too much. And here again, I'm talking economics before I even talk about public health, which our public health professionals have told us for decades we need to quit burning this. So I just hammer away that we got to quit burning coal. If that's the only thing you remember tonight, then I succeeded. Quit burning coal. Now, some of the new things. So I think that's the end of the bad news before you all leave. Now, I want to just poke you through a number of things that I see coming that are pretty revolutionary, and of course you can never tell what's going to succeed in the marketplace. But for example, one of the things they're now looking very hard at is repurposing some of these old oil wells that have already been drilled as geothermal wells. And there's a place in Utah that's already doing tests, so this isn't just a paper exercise. Of course, you get a mile or so underground and it's something like 500 degrees. You know, there's infinite heat down there. And so if you could pump a fluid down and superheat it to 300 or 400 degrees, bring it to the surface and run a steam turbine, then you just produced electric power with no fossil fuel combustion. Our choices of transportation are certainly getting way better. And of course, we all know down here that flying an airplane is unfortunately the worst thing you can do. And you know, it's kind of interesting. I'm a 3 million miler with Delta, being a global scientist. And so I'm one of the biggest parts of the problem probably in the whole state, but not anymore. I'm retired, I hardly ever fly. But we just all have to be honest that when we're flying in airplanes, that is a huge carbon emission source. Cars are a lot better, but still measurable, and public transport is where things get good. Trains, a number of us, I love riding trains, and I wish we could have a train network. When I go to Europe for conferences, I used to always just ride the trains around. I never once rented a car. But of course, the real winner of all is getting out on your feet or your bike. Now, speaking of bikes, I'll confess first that I was a lifelong bike commuter. So I was kind of a bike nut even before climate change came along, and so I have to face up to that. But these electric bikes now are just getting wild. And these are the sort of things they have in Europe. I took all these pictures in Europe. But of course here, you can for under $1,000 get an electric bike. And I know lots and lots of people of my vintage that hadn't been on a bike in decades, and they decided to try one, and now they're just riding all over the town just for the fun of it, because the electric motor just takes the misery out. You're riding along, but when it gets tough, it kind of helps you along. And what it also does, though, is really expand the commuter range. When I moved to Missoula, I wanted to be within 5 miles of campus so I could ride my bike. I ended up 3 miles from campus. Well, if you had an e-bike, you could be 7, 8, 10 miles away if you're in the right kind of road. So it really extends commuting possibilities in a very nice way. And the prices of them have come way down from 5 years ago. Of course, lots of electric cars now. The car industry has made the categorical decision that the future is electric cars. How long it takes for the transition isn't clear, but not one of them is arguing that we're going to stay with ICE, internal combustion engine cars. And so this is where the future is going. One of the things that then opens up, which is one of the ideas that I found very intriguing, is imagine if we all had an electric car in our driveway. plugged into the grid, and the grid needed power, like during a storm, and it just needed peaking power for an hour or two. What if it could draw that peaking power from all the electric cars plugged in doing nothing? It's called vehicle to grid, or V2G. So I didn't think of this, but the minute I saw it, I saw the potential. Imagine if every school bus in the state was electric, and all summer long they were just sitting there at the bus depot with nothing to do except being a huge battery for the electric power grid. Northwestern Energy pays 10 times the price for peaking power during emergencies. 10 times. It happens all the time. And if we had electric buses wired V2G, that could solve that. And oh, by the way, the kids would be riding to school in an electric bus too, instead of a diesel bus. And so this opens up a tremendous potential for stabilizing storage in the grid. Of course, we're familiar with solar panels, but what's come up, in a way you wonder why it took so long, shade is worth something too. During the summertime, shade is a valuable commodity very often. Well, how about if we put the solar panels up so we can make use of the shade too? And so this is, parking garages in Arizona that are in the shade. This is in Germany, where they've shaded the entire rail system with solar panels. So you're not only getting the electric power, but you're getting shade that has value in its own right. In like manner, a pretty new idea is what they call agrivoltaics, and it's the same sort of thing. In the heat of the day, most plants actually go under water stress, and if they get a couple hours of relief in the peak of the day in the summer, they actually grow better. And this has been shown by studies. This isn't just theory. And so they call it agrivoltaic. Here's the cows escaping the sun by standing under the solar panels. How many times have you driven by a field and all the cows are clustered over the one little bit of shade? And so here again, shade is value that a solar panel can provide on top of electric power. And so that kind of double duty payoff they're realizing is worth really thinking about. Oh, this is the one I just heard this last year, and it's called reconductoring. You might have read that the national electric grid is way behind. It's old, it's over capacity. What are we going to do? How are we going to get more grids built? Everybody fights the permitting, and the applications take forever. Well, some electrical engineers at MIT have looked real hard at designing an advanced wire. And they say simply taking the old wires down and putting up these new, better wires could double the grid capacity right there, with no more towers, nothing new except the high capacity wires. And they call this reconductoring. This is one of the best ideas I've heard this year, because it really means we can work with the infrastructure we have and simply upgrade it. And that's just, from both time and money point of view, way ahead of building a whole new grid. Another real advance are heat pumps. Probably a lot of you have these by now, that heat in the winter and cool in the summer, and they do it all with about a quarter the power draw of normal furnaces. And so this is something that's now right on the market. It's nothing new. Food is a really interesting topic in the climate change world. The first thing you typically hear about is, the Earth is going to run out of food, and there's going to be worldwide famine. We just can't grow enough food for all the people. Well, that I'm not actually worried about that much at all. And a lot of it is this. Study after study shows 20 to 40% of all the food grown ends up wasted somewhere along the way and not eaten. That's a gigantic amount of food that never gets used. It starts with our idiotic food date labeling, which, if you don't know, has no legal accuracy one bit and is not controlled at all, and it's just crap. And if people are throwing away food the minute that date label says, you're throwing away lots of good food. Now, my wife says that I kind of err on the other side, and if the cheese doesn't get up and walk away from me, I still eat it. But this is just one small example of how idiotically we currently are running our food system. There's people working on that. A couple of these that I've come across. One's called Too Good to Go. One's called Flash Food. I guess these are networks where they try to organize food that's about to get thrown out and picking it up and using it in some way. Now, I realize this is a two-edged sword. If grocers ended up giving away all their food, they'd go broke. So I understand that this is not an easy issue, but we got to do a better job than we've been doing at how we make use of the food that we've gone to all the trouble to grow and transport and process and store, and then we throw it away. Enough said. Another one. Oh, this is a favorite one when I talk to university audiences. The fashion industry has a bigger carbon footprint than the airline industry. And this came from CBS News, not from some quack. And so the amount of this churn of fast fashion is not good. And this is, again, something that we need to work on. Now, recycling, probably the only thing that really effectively is being recycled right now is aluminum cans and cardboard. And I'm sorry, but anything else, it is very hit and miss whether they're done at all, and even if they try, if it pans out. And so we have so much work to do on that. So as we step back from these issues and look at what the country's thinking about on climate change, this Global Warming 6 Americas comes out of Yale and George Mason University. They've been doing it for 20 years. And they defined the populace into these 6 bins, from alarmed to dismissive. It's interesting that the real hardcore climate deniers has sat at about 10% for 20 years. It hasn't gone up at all. Now, the sad thing is it hasn't gone down either. But the fact is, they might get noisier, but they're certainly not getting numerically any larger. What's happened in the last decade is these kind of middle zone, cautious and disengaged, have started catching on that we're in trouble, and now are showing up at the left side. So when you add that up, of the alarmed and concerned alone, you have 60% of the adult public. And so the majority of the adult public knows that we better get to work. And despite how noisy some of the denier rhetoric is. One of the ways we're getting to work, some of you might have followed that youth climate trial. Yeah, I was the lead witness expert witness for climate on that, so I was in the middle of it. We are waiting to hear a final Supreme Court determination of whether they're going to change anything or not. I really expect it any day right now, but then I don't know a thing about law, so it may not. But that was the first successful trial in the whole world. My friends in Europe read about that. And so little old Montana actually made international news on this event. And I think it'll make international news again, either way, whatever our Supreme Court does, because it's such a lead trial. So one of the things we've seen is that climate denial used to be based on, well, global warming's not happening, and well, everybody knows now that's false. Or that greenhouse gases aren't really the cause. Well, I just showed you way too many ways why we know it's the cause. So now they talk more about, well, global warming might actually be beneficial. And what they're playing with is increased CO2 can be beneficial in the right circumstance. Greenhouses actually pump CO2 in the greenhouse to grow plants faster. But you got to be able to control the climate for that to work. And so the issue here is not our plants growing faster, it's the disruption of climate. And then they claim that climate science is unreliable. Well, thanks, I just wasted my career. And so we're at a pivot point now where we got to make sure that the world doesn't end up here, that we really need to turn this corner and bring emissions down here. And this is IPCC lingo that I won't crawl you through, but it's just what this is the decision space for humanity over the next half century. And it does give you a sense that what we do in the next decade can set a trajectory for a long time. And what climate communicators have found is people are most motivated to do something, not by whether they're going to increase jobs or reduce social inequality. People by far are motivated by concern for their grandkids. By far. And this was across 22 countries. This was a huge, big study. And this was the bottom line, and I'll bet everyone sitting here is saying, yeah. So I started this, and I found audiences liked it, so I worked on it a little more. A free thing, doesn't cost you a nickel to do a few things to lower your carbon footprint. This isn't very popular. I do it, and everybody goes by me like I'm going backwards. And of course, I already talked about riding your bike. We already talked about wasting less food. I happen to have a mental block against clothes dryers. We live in an arid climate. All you do is hang the clothes up and the atmosphere will dry it out. Thank you very much. This incidentally is a battle in my house too. When I'm gone, I know my wife put stuff in the dryer. I'm a lazy sort, so we waste way too many resources on lawn care. Everybody's thought of lawns is based on the climate of London, and for God's sake, we're in Montana. We already talked about at least you should work on recycling your aluminum cardboard. Go digital for your daily news if you haven't already. When I finally did, I realized how many hundreds of pounds of newsprint I took to recycling like 3 times a year. And I thought, man, that is a big difference simply by one family quitting the print newspaper. And then finally, you can cool off a fair bit just using a fan before you need an air conditioner. And I just read a study that says the perceived cooling on your body with a fan is about 6 degrees Fahrenheit. So that means if it's 80 degrees in the room and you sit in front of a fan, your body is experiencing something more like 74 degrees. That often is good enough. Now, there comes a point where it isn't good enough, there's no doubt, but that's an easy thing to at least think about, is when you're just a little bit hot, see if a fan's all you need, because it takes something like 1/10 of the power of what your AC does. 1/10, it's a huge difference. And so my final thought is, This one's been around for a while, but I just can't not keep using it. You know, all these things, improving the world. What if it's a big hoax and we create a better world for nothing? Okay, that's it. All right.
Thank you, Dr. Running. And that was, for all of us, I think, very clarifying and a little bit terrifying. We'll now open the floor for comments and questions. Once again, we ask only that you be A, respectful, and B, observe a 2-minute time limit, which I will be here enforcing. My friend Frank Pelfrey will be down on the floor with a microphone, so just line up at the mic, and we'll just take your questions in turn as you come to the mic. Surely, some of you have questions. Let's see, where's... Oh! Let's see. Sure. I'll give Dr. Running this mic, if you can just...
Well, why don't you give it to him first, and then you can pass it to me in case I happen to have an answer.
Many articles refer to tipping points and concern about tipping points, such as Atlantic currents, the Gulf Stream.
Yeah.
What is your concern? What tipping point are you concerned about?
Yeah, in both the ecological world and in the climate world, we know things aren't linear. They aren't just going to keep linearly getting better or worse. The concern is a tipping point where things would dramatically accelerate. Probably the tipping point that I see most of the climate crowd worried about most is melting of the ice caps that would trigger not only accelerated sea level rise, but it could also disrupt the Gulf Stream, and then to add icing to the cake, melting the permafrost with a big methane burst. And so that's probably the one that is most regularly talked about, and that they are just measuring like mad to see if we certainly want to detect, the faster we detect it, the better chance we have to do something.
And Frank is up there with a microphone if anyone wants to come to him.
With all the recent discussion of the need for increased energy for AI and continued crypto mining and stuff, how does this factor into what we're looking at?
Yeah, I know it was incredibly demoralizing a few years back when I read a paper that said, well, everything the U.S. did in energy reduction last year got eaten up by the Bitcoin crowd. And you just go, are you kidding me? I won't mince any words. I consider the cryptocurrency total bullshit. And if one of you is a big supporter, I'm sorry. But I think it's just a darn shell game, and it consumes gobs of energy. Now, you asked about AI. Now that's a different. So with cryptocurrency, they don't actually provide any service to society at all. With AI, it could. So it's a different situation. The AI used in the right way is already improving things like medical diagnostics and stuff like that. And so that's a whole different argument in my mind than something like crypto that has no social value that I can detect. But it certainly, yeah, I don't have an immediate solution, that's for sure, other than to say that the energy production world is on high alert. A number of the companies like Google, to their credit, they're basically saying every bit of additional energy we need, we will buy from renewable sources. So as our energy consumption goes up, at least we guarantee it'll be renewably sourced. So I like to hope that those big lead players stick with that, because we don't know yet where the value of AI is going to land, but we know there'll be some, and probably substantial in various fields.
One of the things, first of all, thank you for being here. One of the items that you had on one of your slides was talking about coal cleanup, and I didn't see any flesh hung on that bone. Can you share a little bit, please?
Yeah. You should see how many slides I have to take out to keep this talk to an hour. I give a Molly course on campus where I have 6 hours, and that's more like it. Of course, it is spread over 4 days, which helps. Anyway, back to the problem at hand. With coal, burning coal, nobody can argue is a good idea anymore, scientifically, health-wise, or economically. A big issue, though, is all the coal miners that are going to lose their jobs, or already losing their jobs. One of the avenues that could very much solve a lot of that unemployment is the mine reclamation. Take Colstrip. They've been putting away a coal tax fund for decades that I think has something like $500 million or some serious amount of money in it. And that was earmarked for reclamation. So I think an awful lot of these coal miners could go right around to a new job reclaiming those mines, and for just the same sort of wages they're making now.
Hey there. I'm wondering how you would like the government to respond legislatively to the crisis?
At which level? Yeah, see
Whatever you think would have the most effect.
Yeah, see, this is where starting at the global scale where I spent my own science career, it really is demoralizing how many people talk down global governance by whatever label you want to call it. They look at the United Nations, it can't accomplish a damn thing. And the fact is, we have global scale problems, of which climate's only one of them. We got to warm up with COVID is another, and yet we have a very insufficient level of international coordination and governance. And I hear so many people say something like, I'm not going to let some liberal in Brussels, Belgium tell me what to do here. And what they're saying is they don't want to take orders from any other country. They want their own. Well, unfortunately, I don't know how we're going to crack this, a better international governance, but as we push more and more into global scale problems, we're going to be forced to. All right, now let's step down to national scale. I think we've seen in the last few years a couple of the major bills, like the Inflation Reduction Act. This is how the politicians do it. They put that title on it. It should have been the Climate Act, but they weren't about to title it that because it wouldn't pass. And so you think, oh boy, whatever game you play. So on the national level, at least at the moment, not only the US, but a fair number of other countries are making progress. Then you step down to the state level. Well, it's all over the map. if you compare what California is doing with what, let's just say, Wyoming is doing, it's completely different. So at the state level, it's all about whatever their economy is. And so there's very little consistency of the kind of policies or tax credits or regulatory control that they do. And then finally you get to the local level, and it's actually where you can get the most done. And because if a small group of people get organized and think up some good ideas, they can go do it. And so when you say government, I think of that entire spectrum. And it turns out that, at least in the short term, the local scale ends up being the winner. Go figure. I know, I see at least one.
Am I in?
Okay, yeah.
I'm Jim Olson. I got 3 things. First of all, I just went to all the health board meetings around the county, did a book on COVID with a couple of PhDs helping. And what I got out of that, including the denier, the people, the orthodox narrative and the anti-orthodox narrative, all of whom my friend group includes both, is that the COVID caused a lot of people to no longer trust scientific institutions, and they had some reason to do so because, in fact, some people don't want to hear it. The FDA wasn't always doing what they're supposed to do. The CDC was saying things that weren't always true, and they got caught. And so, from an activist viewpoint, of which I am, the question is, well, before I get to that question, this valley is a closed basin, and we are getting to the date of the last septic tank. It's already come up in the health board meetings. We're not there yet, but we are going to get to the point of the last septic tank in this county sooner or later. And of course, when we saw the less rainfall and more population, so get ready for that dynamic. The other thing, I've done a lot of ISR for the defense industry, remote sensing, and I've been a modeler. I've worked on some large scale, some really fancy, highly complicated defense systems, the most complicated in the world, and it's a lot simpler than what you're working on.
Yep.
It's a lot simpler than what you're working on.
Yep.
And one of the systems I worked on was a real-time model of the ionosphere embedded in locatable horizon radar.
Yep.
2 minutes, Jim, if you can get to the question. Or if you have a question.
So two questions. One is, I'm going to say that you're doing a very complicated model. I've looked at some of the papers. You're going to keep learning some things that you don't know now in that model.
Yeah,
I think
for sure.
I think that's a given. Okay. And the second thing is that how does the climate change group deal with that lack of trust?
Yeah.
That was already there before COVID. It was made worse over COVID. That's my question.
Yeah, as scientists, and I talk with a lot of my friends about this, the erosion of confidence in science in general of the last 5 years is quite demoralizing to a lot of us in totally separate fields, and we're just getting the blowback that suddenly, it used to be when they'd list the most trusted occupations in the country, science was usually right up 1 or 2. And so to see us having lost that in fair measure, starting with the COVID problems, we kind of don't know what to do except to keep just telling the facts as best we know them. And yet I know we've lost some of our audience that somehow they think they have better facts. And so I don't have a real sharp answer for you, other than I keep showing up and doing things like this. And everything that I showed are direct measurements that I could take you right to the source.
Basically right here.
Hi, I was wondering, can you expand upon the V2G vehicles, how they can contribute in terms of giving energy back to the grid?
Yeah. Elon Musk wants to sell you a power wall, which is a big stack of lithium batteries that you have in your garage, and your solar panels would charge up your power wall, and then if the power goes out, you run your house with your power wall. Well, what if the power wall had wheels on it? It's kind of no more complicated than that in principle. Your car has at least the modern electric cars with, say, 300 miles of range have about the same amount of power capacity as a power wall, and yet you can use it to drive around town too. And so when you recognize that electric car, that battery in that car has capabilities that if it's just sitting there are being wasted, by tethering it to the grid and allowing it, rather than simply charging the car from your house, the car can charge your house in return, or the grid in return. That's the basic idea, and it's already well established and being tested. I think there's a big test in Baltimore right now with their local energy company. So this is an idea that's made it off the drawing boards. And the minute you start thinking of millions of electric cars with these huge batteries, and you start thinking we could be using those batteries when that car is sitting around doing nothing.
Is there a parallel global negative health implication and therefore an increase in health costs either now or projected for the future?
I think I understand what you're asking. In the climate change science issue, are there health topics that are big?
That are parallel and caused by the declining climate?
Yeah, well, probably the clearest probability, I won't even say possibility, is some of these tropical diseases and things like malaria coming to the temperate zone. And so all the malaria and dengue fever and Ebola, and you go down the list, and I've got to remember I'm in an NIH town, don't I? There's probably half the audience probably knows more about this than I do. But and so that's probably the biggest one that I regularly see, is tropical diseases that in the past have been limited, particularly by wintertime freezing, that are sneaking north, and they're already measuring it for sure. So it's not hypothetical. I'm sure there's other ones, but that's the one I see the most commonly talked about.
Dr. Russ, thank you for being here. I just can't happen to see on all my feed of the sharks and things attacking boats on Cape Cod or anywhere around. I used to fish the ocean. I think that you mentioned in your text that it affects the ocean first, and I really think they're mad at us. Coming up, and like eating part of the boats, well, we've never heard that before. Or do I have too much media going on? I'm not sure, but I'd like to hear your comments on that.
Yeah, wasn't there an orca that was smashing into tuna boats just a couple of months ago? Yeah, and so You know, I'm a terrestrial biologist, so I'm not up particularly as much on ocean biology. Maybe ocean physics I can handle. But I know, for example, that the ocean fish catch is not sustainable one bit. And in fact, farm-raised fishing is saving the native populations from completely getting fished into extinction. So when you talk about humans overrunning the planet in various ways, ocean fishing is exhibit A. And of course, here we go again. There's no international legal control. So once you're out on the open ocean, I think there's some treaties that are broken every day of the week, but we just have such weak international governance that once they're in the ocean open, I'm probably about done for. The open ocean, they can do whatever they want. And they've got these huge, big factory ships that can catch and process infinitely more fish than they could 50 years ago.
I would like to ask why such a forward-thinking city like Missoula only recycles plastics, ones, and translucent tubes. And we make such a big deal about recycling. We work really hard to clean all those bottles out, but there's nowhere to take them except for Spokane. And I just don't understand why we're so slow to really actually recycle some of these other plastics.
Yeah, I think you summarized the state of recycling in Missoula, and it's all about whether the recycling company can get anybody to take it. And you're right, they have to drag so much of this to Spokane. There's just no local market for the plastics. I don't even think for the tin cans, certainly not for the glass. It really kills you. You know, we can't recycle glass. It takes more energy for whatever processing you end up doing than pans out. And so recycling as an issue, and Missoula isn't all that far behind most other cities. I was just reading today a summary of plastics recycling nationwide, and it's in sorry shape everywhere.
Dr. Running, can you compare the energy drain for the cloud compared to like cryptocurrency?
Okay, cloud computing versus crypto.
How bad is the energy drain?
It's big. Okay. If you've got nothing to do in the next few weeks, drive down the Columbia River to Portland. And along the Columbia River, you won't believe how many odd-looking concrete buildings with no windows in it, and hardly any cars out front. And what's going on? Well, that's all server farms. And they're just piling into the Columbia Valley because of cheap hydroelectric power, and they use gobs of electricity. And so the good news is the computer architecture is getting more efficient. A computer can operate with less power than the ones 10 years ago. But on the other hand, between cloud computing and then crypto and now AI piling on top of it, we're just finding more and more ways to use the computing network that we wonder where the end is, because those things are all really big.
I'm going to borrow the mic for just a second. So.
A question about modeling. which is very important in climate science. And
Yeah.
I've done a little modeling myself in my career, and I remember the quote, "All models are wrong, some of them are useful." But how is the modeling doing? Are they getting better? I think somebody said 2023 was pretty bad as to the predictions there.
I assume when you're saying, asking modeling, it's the climate modeling. Yeah, okay. The interesting thing with the climate modeling, and I was in it for my whole career from the land side, they used my algorithms. The computers would get bigger, and so they'd put more in them. And what's interesting is if you stand back for the just overall approximate rate of temperature increase per unit CO2, it hasn't changed much in 20 years. The estimates of 20 years ago are about the same as it is now. But it's just at that highest level of generality. They compute a lot more detail. The biggest thing is now that the models have a lot more realism in them than they used to, they can play lots of what-if scenario games. I give you an example. When I started in 1980, the climate models did not have the vegetation in them at all. None. There was an ocean and there was land that was just kind of bare desert. Okay, and then as my career went through, we were able to get the biosphere in, and the atmospheric scientists didn't want us because we added a whole bunch of complexity they didn't want to deal with. But and now we're adding, soil processes. We're adding disturbance dynamics like wildfires, and so they would keep adding more and more dynamics. It allows you to use the model to try to understand future potentials, but in terms of just raw estimates of how global warming is going to proceed, they haven't gone down, but they haven't gotten particularly all that much better for just the overall estimate forward. And it's been funny to watch since I've been in the middle of it the whole time.
Dr. Running, I have a question. Occasionally I read an article or see a story about efforts to come up with technologies that can extract carbon dioxide out of the atmosphere.
Oh,
Do you
yeah.
have any comments on?
Oh, yeah, I have lots of comments on that. That's the fossil fuel favorite, because that allows them to keep burning fossil fuels and then sucking it back up. And we know how to do it. We could suck up CO2 out of the atmosphere or out of the smokestack at Colstrip and compress it and squirt it down underground, carbon sequestration. The thing is, you melt through so much money doing it that same money you could be handing out solar panels on the street corner. And so if you compare doing the carbon sequestration against all the other alternative ways you could use your money, what do the economists call it? The opportunity costs. You could use your same $1 billion a dozen different ways better. And so that's what they never tell you when they say that they're successfully resequestering CO2. They give big government grants. They've got hundreds of millions of dollars. They set up the plant. They run it for a couple months and say, gee, this doesn't pencil out. And then they quietly shut down after they pocketed the grant money. And of course, they whine about the solar industry all the time. And I would love to show you the carbon sequestration game that does exactly this endlessly and forgets to tell you how financially ridiculous it is.
Steve, right here.
Okay.
I've got something you add to things people can do for free.
Okay, good.
And that would be take advantage of the Inflation Reduction Act. The Montana DEQ will have its act together next year, and there's gobs of money coming that we could get great improvements to our home
Yep.
paid for by the Inflation Reduction Act. And you can get on the DEQ's email list to see how they're doing when they come out with that. And you just showed one slide about an air source heat pump.
Right.
We could stop heating our homes with gas
Yeah.
almost for free because of the Inflation Reduction Act.
Yeah, I was listening to an NPR show on the way down here that said across all the states in the country, the average is they've only tapped about 7% of the available financing from the IRA. 7. And so there's just gobs of money already authorized for all sorts of renewable energy and energy efficiency projects. You're completely right. And part of it is because the states had not got their system in place to deal with the applications yet. And so hopefully our DEQ is ready to go for next year.
Hi. So you talked about electric cars a little bit, and there's kind of, even looking at electric cars with the reduction compared to ICE vehicles, there's still a higher net impact compared to other forms of transportation. And there's people that would say that we kind of need to shift our consumption habits and have a cultural shift overall versus like electric cars are keeping the car industry relevant, some would say. So do you think it's safe to rely on technological advancement and implementation of renewable energy to solve the problem without having to do any kind of big cultural shift?
Yeah, we've been encouraging cultural shifts for decades with rather limited success. As I say, I was a lifelong bike commuter, and I've given endless talks encouraging people to ditch their car and ride their bike to work. has a parking crisis every year that could be solved if half the staff would ride a bike, for example. And so, I have all sorts of, what should we say, lifestyle choices that we could have a whole nother talk about those. I try to, quit using your clothes dryer. There's a lifestyle choice that my own wife won't even do completely. So that's where reality hits. Electric cars certainly are a way better transportation option than a gas engine car. And so it is a step ahead to turn our cars from gas to electric. And that's clearly been illustrated by lots of studies. And as we drive the lithium battery costs down. But it's certainly true that an even better solution would be more public transport and more people riding their brand new e-bikes. I don't get a commission from the e-bike company. I just am an e-bike nut. I'm sorry. I'm at least admitting it.
I have a question. How do you feel about companies buying carbon credits?
Oh man, is that a good one? Yeah. I give this crowd credit. These are really insightful questions, all of them. And it makes me feel like this has been a success.
I had a question of how does nuclear energy play into all of this?
Oh boy, yeah, another one. I continue to be neutral on the nuclear question. People for a long time thought I would be an adamant anti-nuclear sort, and I'm not. But I read over and over and over again, they just can't seem to close the gap financially. It's kind of like the carbon sequestration. It costs so much for even these new design modulars, which sound on paper to be so good. When they build a prototype, it's way over budget and late in schedule and over budget. And I keep hoping that the industry will mature, but they've been talking for so long, it's time to quit talking and show me. And they haven't done it yet. And I know they're building one at Idaho National Lab right now. My son-in-law works there. So I'm watching this pretty carefully. And you just hope they can come through with designs that are safe, efficient, and cost competitive. But they haven't done it yet.
I have a comment about regeneration. It was mentioned in one of your slides.
Okay.
And in a historical context, in of all things, the railroad business, back 100 years ago approximately, a transcontinental railroad, the Milwaukee Road, electrified through to the coast from Chicago. And it ended up, everyone in the industry would say a failure, but there were political and economic reasons involved. That concept of regeneration was scrapped in the 70s. Until then, they ran transcontinental trains with electrification. The Montana State Big Sky Passenger Rail Authority has had some seminars lately, and that concept is being advanced, but it's an example of how government versus industry versus bad management can really run amok. And I'm wondering, the question is, what are the odds that we're going to be able to pull this off?
Are you referring particularly to the Big Sky Rail?
No.
Okay.
To basically reaching the climate goals that we're aspiring to.
I have to ask the time frame. Over the next 30 years, we're going to go past 1.5. We already have gone past 1.5. In the short run, we're not making the pace that we need. You like to hope that end of the century is still 70 years away. A lot of things can happen in 70 years. So if you allow me to have a long enough time frame, I'm pretty optimistic. But over a shorter time frame, I can't be Pollyannish that we're doing great, because emissions are still going up. Now they say China may peak this year. And if China peaks, then that means the world peaks in emissions. And so stay tuned, we're crawling forward.
Maybe two more questions. You got, how are you feeling about?
I got all night. Now that I have a chair, I got this here chair, so I'm quite comfortable.
Electric cars are obviously very important in trying to solve the climate problem, but they also have a problem, which is those batteries that it takes to make it makes like gigantic mines, like the one they're trying to put in at the headwaters of the Bitterroot. And basically, do you think that having to make mines for a problem this big kind of is worth it in this sense, or should we wait until we figure out how to make hydrogen-powered batteries and cars?
Let me answer homing in on the lithium industry specifically. I read regularly of improvements in strategy of lithium extraction, and particularly in lithium brine like the Great Salt Lake. They've just figured out a way to extract the lithium for about a third the energy and cost that their current methodology is. So there's no doubt that a lithium mine in the wrong place we're not going to be very happy with. But I'm also seeing an awful lot of progress in lithium mining technology, and the batteries are using less and less lithium per kilowatt produced. So they're getting more efficient in how they use it. So in both directions, the news is getting better slowly. But that doesn't mean we don't want to stay on high alert for mines in the wrong places, that's for sure. Yeah.
If you don't mind, I'd like to address this cloud crypto.
Oh, okay.
How many people have one of these in your pocket? The processing isn't happening on this thing. It's happening in the cloud. So let's get real here. That's the first thing. It's not the cloud so much. It really is crypto mining and AI. I just want to be clear about that. Crypto mining uses far more electricity than almost anything else, except maybe as AI takes over. It's just, that's what's happening. And, you know, as you said, and I agree completely, the speculative currencies are exactly that. It's a pyramid scheme, just so you know. Those people who get in early are very wealthy. Those people who come later are not so wealthy. It's just the way it works. However, I do want to say it's a little bit complex, because we have a fairly stable currency. It may not seem like that when we get inflation like we've had recently, but we have a stable currency, our fiat currency, and in a lot of places it's not so stable.
That's true.
And those people love the crypto that is tied to a stable currency, because it means when they get paid and when they spend, they have more or less the same value, as opposed to have lost it, whatever the problem is. So, you know, it's a little bit more complex than it is just saying, okay, all crypto's bad. You know, I want to point out that for many people outside our little bubble, crypto, getting paid in crypto is a blessing.
Yeah. I have friends in places like Argentina where they would be having, I don't know recently, they'd be having inflation of 100% per month, not per year. They would get their paycheck and run straight to the appliance store and buy something that day, because it'd be 30% higher the next morning. And so absolutely, as a stability point for people like that, that's a good point to make in a little bit of defense of crypto.
That part, just that part.
Yep. Yeah, right, of that part.
I was wondering, like, you were talking about cutting out all of the greenhouse gases and trying to limit those and all the fossil fuels. How long would it take, like an estimate of how much it would cost trying to get rid of that, mostly in the United States? And like how much emissions would we create trying to make all the parts to make renewable energy?
I'm not sure if I register. Try asking it again. I can't quite grasp the question.
I was wondering if there's like an estimate on a timeline and cost for trying to cut out all of the fossil fuels, and when we were doing that and replacing the fossil fuels with all of the renewable energy sources, how much emissions would potentially be emitted when trying to create parts for renewable energy sources.
I think I've got a little bit, through different parts of the economy, the answer, as you might expect, is way different. Electrical production is actually the easiest because we have so many other choices that can be deployed all around the country. Transportation for private vehicles is pretty easy. We're on our way. Don't ask me about airplanes though. I have not seen all that much progress in particularly airplanes that would be transatlantic sort of capacity. And so that we don't have solutions on deck. Some of the heavy industry they have a hard time with going to renewable industry. They're working on steel smelters, for example, that would be run by electricity rather than coal. And so there's not a single answer to a question like that. One of the kind of side benefits, though, the fossil fuel industry alone, for its own energy production of drilling and transporting and refining and hauling all the fossil fuel all around, their own carbon footprint is really big, and that's before you burn the fuel. That's literally going and getting it and processing it and dragging it to wherever we pick it up. And so as we diminish our fossil fuel use, there's a little multiplier effect there that's in our advantage, that means they don't have to spend as much fossil fuel in their own production and refining and processing.
Maybe one more question we are going to have to.
Yep, okay, yeah, we're going to get thrown out of here, aren't we?
What?
Go ahead.
So I'm kind of curious, I've thought about this a long time. You plug your electric car into the electric grid, and where's the power coming from? It's coming from coal strip, fossil fuels, right? I mean, how?
Not necessarily. A lot of ours comes from Bonneville hydro dams, or in my case, from my solar panels.
Okay, so if we all switch to solar panels, then it'll be efficient. Most of it.
Well, depending on where you are in the country, you certainly have a point. If you're juicing up your electric car from a coal plant, it's nowhere near as good for the world as if you're juicing it up from solar panels. So, and there's places that are still pretty coal heavy in their electric power.
So what do you think about hybrid cars?
I've got one. In Montana here and with our charging network, it's a little bit, I've got a hybrid. I can plug it in and drive it all around Missoula for free, but when I need to go to Spokane, I think that's going to be a while for our communities like ours, where driving, to Billings, I got to go to Billings tomorrow, and if I had an electric car, I would have a big charging stop somewhere. So I think everybody has a different lifestyle and needs, and different parts of the country are in different conditions. But I think full electric still is. If I had a few days, that'd be. What if the headwind came up, though?
Well, then you can charge it from wind power.
That's right.
Yeah, I would like to ask a question about our cultural change or shift you mentioned before. Things we can do, of course, on a personal level. I would be interested, do you think that our very recent, maybe 100-year-old economy system, I studied economics, is it fit enough for the future to implement our culture shift? Because it's driven by more sales still, mostly, with a few exceptions. So if we need more sales in order to keep our life standard up, what we can enjoy mostly. So is that compatible with all the other ideas?
Around the university, I give a talk regularly on kind of capitalistic theory, let's call it. And I start, some of you in this audience might remember the old book, The Limits to Growth, that came out in 1972 from MIT, where they made a very trivial little global model, but basically illustrated that by around now, we're going to overwhelm the world in just raw consumption. And so I've got a whole talk on on whether capitalism is going to be the end of us or not. And I find that for a talk like this, it gets a little too esoteric for most audiences.
Thank you, Dr. Running. Thank you all for coming out tonight. Please take advantage of the materials that are available at the table out in the hall. There are also some refreshments out there. We have a building till 9:30, and then the janitors will be sweeping us all out. Thank you for coming out tonight, and thank you, Dr. Running.